Hello, everybody. In this video, we're going to take a look at a tutorial on working circuit puzzles 9, 10, and 11. Again, just as before, please pause the video and try these yourself before you watch the solutions to see if you are indeed learning how to apply Ohm's law and your series and parallel rules. Again, as a reminder, use Ohm's law across the rows from V to I to R. Use Joule's law, power equals current times voltage, only at the very end. Use your series parallel rules down each column, specifically voltage and current. Lastly, if all your individual powers add up to the total power you calculate by going current times voltage, we know we did the circuit correctly. So let's begin with number 9. You can see one of the very first things that I want you to be able to do is trace the current through the circuit. Now, I took the liberty of doing this one so I could color code it for you. The total amount of current comes down from the positive side of the battery. Let me go ahead and annotate that. So there's the positive side of the battery, there's the negative side of the battery. The current comes down, whatever the total current is, comes down, goes across R6. That means resistor 6 is getting whatever the total current is. Across R5, R5 is receiving the total current. There we go. The total current, 5 amps. And that total current then splits not 1, not 2, not 3, but 4 ways. The black current, which is 5 amps, has split into blue, gray, and dark green. Well, light green, and the light green splits into dark green and yellow. The whole point is that it's splitting a total of 4 ways. So looking at this right here, I do see one thing that we could do to start. I would encourage you to use Ohm's law to start because it's an easy calculation. I times R is voltage, V divided by R is current, V divided by I is resistance. I see 5 amps times 5 ohms to give me 25 volts. So on R5, I'm going to go ahead and annotate the circuit as we go. 25 volts. And I also know that there's 5 amps of current going through this resistor number 5. I also see that resistor number 5 is in series with resistor number 6 and the battery. And what do we know about current in series? We know that current in series is the same. So if this is 5 amps, that means the current here is 5 amps. It also means the total current that came from the battery is also 5 amps. So you can begin by doing a lot. You can start by filling out 5 amps here and 5 amps from the total battery. Well, then, let me see. We can do Ohm's law on resistor number 6. 5 amps times 6 ohms is 30 volts. So there is a voltage drop of 30 volts of potential across resistor number 6. Okay, so whatever the total voltage is, we're going to be subtracting 30 volts across here. We'll be subtracting another 25 volts across here. Okay, so now we have this 4-way split. And we don't know much about this 4-way split. We do know 2 pieces of information about this 4-way split. Okay, and I don't mean your resistances yet. Resistance doesn't really help you that much when it comes to doing circuit analysis. It can, but there's other things we can look at in our chart here. For instance, we know that a total of 5 amps has split 4 ways. We know one of those 5 amps goes along this bottom yellow pathway. That means the remaining 4 amps is splitting somehow 3 ways here. Now, we are not guaranteed that they are equal resistance. In fact, we know they're not equal resistance. 20 ohms of resistance across the blue pathway and only 4 ohm resistance across the dark green pathway. We know since they're not equal, you're not going to be splitting 4 amps equally. So we have to figure this out another way. Well, what we do know is that this is a parallel split. And in parallel, we know the current is summed. Well, we know that. We know that 5 amps goes into this junction, and we know that 5 amps comes out of this junction. So that means 5 amps these currents have to add up to 5 amps. That's fine. Problem is, we don't have enough to go by to add them yet. But what else we know is that in parallel, the voltage is the same. And we do know across the gray pathway from here to here, there is a potential difference of 10 volts. That means there is a potential difference of 10 volts across the blue pathway, across the dark green pathway, and across the yellow pathway. Voltage in parallel is the same. So I could fill out a lot. 10 volts, 10 volts, 10 volts. And that opened up quite a bit already. I can use Ohm's law to find current through resistor 1. Current is voltage divided by resistance. So 10 volts divided by 20 ohms is half an amp. Resistor 3, 10 volts divided by 4 ohms is 2.5 amps. So I know that I can fill out some stuff along the way. I just got to be able to use my chart correctly. The important part is to know what you're looking at. In the beginning of the problem, I was looking at a series connection between R5, R6, and the battery. Now I know current in series is the same. Here I'm looking at a parallel connection, and I know parallel voltage is the same. So we have to use our rules effectively in order to do this. And then use a little Ohm's law to help, fill in the gaps. For instance, finding resistor 4, we can do that by going 10 volts divided by 1 amp, which is 10 ohms. And lastly, we can find the current across resistor 2. We know the current across resistor 1 was half an amp. We know the current across resistor 3 was 2.5 amps. Okay, so now if we start adding some stuff up here, 2.5 plus a half is 3 amps. Plus 1 amp is 4 amps. That means the remaining amount of gray current has to be 1 measly little amp. Okay? So again, we can figure some stuff out by using our rules. So if that's 1 amp, 10 volts divided by 1 amp is 10 ohms. We have almost everything figured out. Now we got to figure out the battery voltage. Well, we know that this chunk, we know that whatever voltage we have, okay, is going to be subtracting 30 volts, 25 volts, and whatever the voltage across this chunk. The voltage across this whole bit here, from here to here, is 10 volts. It doesn't matter that there's 4 resistors in parallel. The potential difference from this point here to this point here, which happens to split 4 ways, it's the potential difference from that point to that point, and it's all the same. It's all 10 volts. So here's what we do. We take these voltages and we add them up because this is a series connection all the way around the circuit. 30 plus 25 plus 10. And if we take 30 plus 25 plus 10, we get 65 volts of total potential across the entire circuit. So if we follow the logic here, we would have 65 volts of potential on the positive side and 0 volts of potential on the negative side. As we go across the circuit here, we are at 65 volts right here on this side. And there's a voltage drop of 30 volts to go from this side to this side across this resistor. So 65 minus 30 would bring us down to 35 volts on this side of the resistor. And crossing this resistor, we drop 25 volts of potential from 35. So now we would be down to 10 volts of potential. But we can see going into the last bit of resistance, we are dropping 10 volts of potential, which brings us down to 0 volts. Okay, the sum total of the voltages have to add up to 0, meaning you subtract the voltages you go all the way around until you get to 0. So it checks out. Let me fill that in. And we can take 65 divided by 5, and we can see that the total resistance here would be 13 ohms of total resistance in the circuit. Let's find our powers. Okay, total power, 65 times 5 is 325. 5 times a half, or 10 times a half would be 5 watts. 10 times 1 would be 10 watts. 10 times 2.5 would be 25 watts. 10 times 1 is 10 watts. 25 times 5 should be 125 watts. Let's see, 30 times 5 should be 150 watts. Now, last step, let's go ahead and add up all 6 of these resistor powers and see if it adds up to 325. So 5 plus 10 plus 25 plus 10 plus 125 plus 150. Indeed, it does add up to 325 watts. We know we did this circuit correctly. Let's move down to circuit number 10. Circuit number 10 is interesting because we have our total battery voltage, which is 30 volts, okay? And I'm going to rewrite this a little bit differently. I'm going to put the 30 volts down here, and I'm going to put the 0 on the negative side. Well, as we go across resistor 6, this group here, resistor 3, and this group here, you're going to drop voltage until you get to 0, okay? Because we have a series circuit that has 2 parallel splits. Follow the current. That should be the first step. The black current, the total current, goes down across resistor 6. That means resistor 6 is getting total current, whatever that total current is. That total current seems to split up. Some of it goes across resistor 4, some of it goes across resistor 5, the dark green and light green. The current adds back up to the total current, which goes across resistor 3. So resistor 3 is also receiving total current, just like resistor 6 was. That total current yet again splits up into the blue and the gray. Now we've arrived at something. If you take a look, the only thing I have to go on in an Ohm's law calculation is finding resistor number 1. But I can do that. 6 volts divided by 3 amps is 2 ohms. That's fine. The problem is I have a lot less information, okay, in bits and pieces here. Resistor 1, I am told, is 6 volts of potential difference from here to here. I'm told that there's 3 amps. Okay, I'm told that there's 2 amps of current across the gray resistor. That is a lot of information here. We know the total current splits into the blue and the gray. Well, if the blue current is 3 amps and the gray current is 2 amps, then that must mean that 5 total amps is adding together. That must mean there was 5 total amps coming into the junction. That must mean that there's 5 amps across this here. Okay, so let's fill that as we go. R3 has 5 amps. It also means that the dark green and the light green, right, split into 5 amps. Okay, 5 amps come in, 5 amps come out. We know 1 amp goes across the dark green. That means the light green on R5 is got to be 4 amps, right? 1 amp plus 4 amps is 5 amps. So we are filling out a lot of the puzzle with just using this notion right here of parallel current being summed. So we're doing that part right now. And then part 6, resistor 6, is in series with this whole thing and is receiving total current. The total current, as we figured out already, is 5 amps. So not only is that 5 amps, but also coming from the battery is also 5 amps. So we have figured out a lot. 5 amps total current, 5 amps through R6. Now let's see what we can do with an Ohm's law calculation here. I see resistor 3, we've got current and resistance. 5 amps times 3 ohms is 15 volts. I see we can figure out resistor 5, 8 volts divided by 4 amps is 2 ohms. And that looks about it. Okay, well, we could find the total resistance here. 30 volts divided by 5 amps is 6 ohms. We could do that. But now we're stuck with some voltage pieces of information we've got to fill in the gaps. Okay, so let's go back to the puzzle. Not much I can do with resistor 6. All I know is the current across it. I don't know the resistance. If I do know the resistance, then I can calculate and find the voltage, but I don't know that. Resistor 4, okay, I do know resistor 4 has a current of 1 amp, and I know resistor 5 has a voltage of 8 volts. Well, resistor 4 and resistor 5 are in parallel, and parallel voltage is the same. So that means if there's 8 volts across resistor 5, then that means there's also 8 volts across resistor 4 because they're in parallel. So I've just filled that one out. And 8 volts divided by 1 amp is 8 ohms using Ohm's law. Similarly, resistor 1 and resistor 2 are in parallel. Since we are told that resistor 1 is 6 volts and parallel voltage is the same, then that must mean that resistor 2 is also 6 volts. So we can fill that out accordingly. And 6 volts divided by 2 amps is 3 ohms. So we have filled out quite a bit. Now we just need to figure out what this one particular voltage is here. So let's try and figure this out. We know we start with 30 volts, and you're going to subtract the voltage around the way. So this right here, this is a big question mark. I don't know what that voltage is. I do know the voltage across this chunk that we subtract from 30, okay, would be minus 8 volts. Let me just type that in. Okay, it would be minus 8 volts. So there's a negative, there's a voltage drop. We subtract 8 volts. So far we have 30 minus 8 is 22. Across R3, we calculated 15 volts of potential difference drop across this resistor. So that means we would drop another 15 volts. So let's do the math here. 30 minus 8 is 22. Minus another 15 is 7. So now we're down to 7 volts of potential for the circuit. But right here, you can see that for this chunk, both of them have the same voltage, and we are subtracting 6 volts of potential across this particular chunk. So we were at 7. 30 minus 20 minus 8 is 22, minus 15 is 7. Minus 6 is 1 volt. Well, we're supposed to be down to 0. So what does that mean for R6? R6 has 1 volt of potential difference across it. Now, remember, the voltages will subtract to 0, but another way to figure this out is to simply add the voltage around the circuit and see if it adds up to the original voltage on the battery. So 1 plus 8 is 9. 9 plus 15 is 24. 24 plus 6 is indeed 30. It checks out. That's 1 volt. 1 volt divided by 5 amps is 0.2 ohms. So let's go ahead and do the math on the power. 30 times 5 is 150. 6 times 3 would be 18 watts. 6 times 2 would be 12 watts. 15 times 5 should be, what, 75 watts? Yeah. 8 times 1 is 8 watts. 8 times 4 is 32 watts. And 1 times 5 is 5 watts. Let's double check by adding up all the individual powers and see if they add up to 150. 18 plus 12 plus 75 plus 8 plus 32 plus 5. Indeed, these all add up to 150. We know we did circuit puzzle number 10 correctly. Lastly, moving on to our final puzzle, number 11. It looks a lot more complex than it is, but what we have here is we have a total amount of current, which in this case is 12 amps, and that total current goes across resistor 7. That total current splits into the blue and the gray, recombines to the total current again, which goes across R4. That total current then splits 3 ways, dark green, light green, and yellow. And that total current recombines and comes back to the battery again. So what we see is we see 1, 2, 3, 4 chunks in series all the way around the circuit. Now, let's see what we know. Well, we know that R7 is in series with the battery. And we know that in series, current is the same. So let's take a look at everything that has total current. Total current is 12 amps. R7 is in series with the battery and is receiving the black current, so that's total current. So I can label 12 amps across this right here. And I know that total current is going across R4, so I can label 12 amps across this too. So let's fill out some things here. R4 is 12 amps, and R7 is 12 amps. The next thing I know is that the total 12 amps splits into the blue and the gray. Well, the gray, as we see here, is 8 amps. So that must mean that the remaining blue current has to be 4 amps. How do I know this? because the 4 amps plus the 8 amps has to equal the 12 amps. There was 12 amps going into the junction. There's 12 amps coming out of the junction. So the remaining current must be 4 amps. So I know that R5, the blue current, is 4 amps. So we're filling out a lot here. Well, the next thing I know is I have 12 total amps, and those 12 total amps split 3 ways. Now I do know the light green current is 2 amps. I don't know the dark green, nor do I know the yellow, so I can't really figure it out yet. I just know 12 amps splits 3 ways. So the remaining 10 amps is the dark green and the yellow. We can figure that out in a minute. Let's fill out some of the Ohm's law portions that we can do here. For instance, resistor 4, the voltage is going to be 12 volts or 12 amps times 4 ohms or 48 volts. Resistor 5 is going to be 4 amps times 2 ohms or 8 volts. And the resistor itself for resistor 7 is going to be 6 volts divided by 12 amps or half an ohm. Okay, so we know that so far. Now, we are kind of stuck. We can't use Ohm's law, and you can't really do anything with current and parallel being summed because we have too much unknown information. But here's what we do know. We know the voltage across pathway number 2 is 18 volts. Since pathway number 2 is in parallel with resistor 1 and resistor 3, we know resistor 1, it also has a potential difference of 18 volts across it. And resistor 3 has a potential difference of 18 volts across it. So I know this is 18 volts, and I know this is 18 volts. A lot more information just filled out. I can now find the current going across resistor 3 because I have 18 volts and 3 ohms. So if I take 18 volts divided by 3 ohms of resistance, I get 6 amps of current. There we go. So we know that there is going to be 12 total amps coming into the split, and we know there's going to be 12 total amps coming out of the split. We know from that 12 total amps, 2 and 6 make 8 total amps. That must mean there is a remaining 4 amps going across the top of the pathway. Okay, we have again filled out quite a bit. Let's use a little Ohm's law here to fill in some of the remaining gaps. Let's see, 18 divided by 4, I think is 4.5. Yes. So 4.5 ohms of resistance across resistor 1. 18 divided by 2 should be 9. And we're kind of stuck on resistor 6. So let's come back to resistor 6. Well, here's one of the things we know. We know that resistor 6 had a calculated voltage of 8 volts across it. And we know that resistor 6 is in parallel with resistor 5. So parallel voltage is the same. So that must mean resistor 6 is also 8 volts of potential difference across it. Okay, and if we go 8 divided by 8, 8 volts divided by 8 amps, I get 1 ohm resistor. Now let's figure out what this battery voltage is. Okay, that's easy. All we have to do is add up the voltages around the circuit. So I'm going to add up 6, 8, let's see here, across R4 should be 48 volts. Okay, so 6 plus 8 plus 48. Why are we adding? Because it's a series circuit all the way around, series chunks that have parallel splits. And then we're going to lastly be adding the 18 right here. So let's add up all those parallel chunks of voltage. And we have 18 plus 48 plus 8 plus 6. And we end up with a total of 80 volts of potential difference across the battery. So to reiterate what's going on here, if this is indeed 80 volts on the positive side, and that's indeed 0 volts on the negative side, then what we do is we start with 80, we subtract 6 volts of potential drop across resistor 7. So 80 minus 6 is now down to 74. Across this parallel chunk, we have now subtracted. We have a voltage drop of 8 volts. So minus 8 more volts. We're down to 66 volts. Across resistor 4, we're dropping 48 volts. So 66 minus 48 is down to 18 volts. And if we deal with the voltage drop across this chunk, which happens to be 18 volts, if we subtract 18 from 18, we are down to 0. So indeed, it checks out. 80 divided by 12, 80 volts over 12 amps gives you 6 2/3 ohms of total resistance. Let's go ahead and figure out our power and then finish out this problem. So 80 times 12 is 960 watts. 18 times 4 is 72 watts. 18 times 2 is 36 watts. 18 times 6 is 108 watts. 48 times 12 is 576 watts. 8 volts times 4 amps is 32 watts. 8 volts times 8 amps is 64 watts. And 8 volts times 12 is 72 watts. Last step, go ahead and add up all these individual powers, and let's see if they add up to the total power of 960. 72 plus 36 plus 108 plus 576 plus 32 plus 64 plus 72. Indeed, all of these powers add up to 960. We know we did circuit puzzle number 11 correctly. I hope you have a better